First, we simply plug in x equals 0. X is approaching to 0 from right side, so this x is 0 times natural log of 0. Just look at the graph of natural log of x. Okay, this is 0. When x approaches to 0, the graph is going to very small. That's negative infinity. 0 times negative infinity. Okay, do not assume 0 times anything is 0. Okay, that is not true. 0 times finite number is 0, but negative infinity is not a finite number. In fact, this is an indeterminate form. But this is not in the nice form we like, because we know when we get 0 over 0 or infinity over infinity, then to evaluate the limit, we could apply L'Hopital's rule. So we don't have one of these two forms. But we can make 0 times negative infinity as a fraction, and maybe 0 over 0 or infinity over infinity. Let's see. Okay, so I want to make this is x times natural log of x as a fraction. So limit x going to 0 from right side. Natural log of x, let's leave there and bring x to the bottom. Let me show you one thing. When we have, like, let's say a times b, then we can make it as a fraction in two different ways. Keep b on the top and divide by reciprocal of a, 1 over a. Okay, when this goes to the top, it's same thing. Or you can change a times b as keep a on the top and move b on the bottom, writing reciprocal. B goes on the top, so we get same thing. Okay, so we're going to use one of these so that we get a fraction. And let's not move natural log of x from the top, so leave natural log of x on the top, and this x, when we put on the bottom, just the reciprocal of x. It's like using this one. Okay, b over 1 over a. Okay, this is 1. Now let's plug in x equals 0. So natural log of 0 from right side, so we get negative infinity on the top, and 1 over 0. Okay, that's infinity. So we have infinity over infinity. That means this fraction qualifies, this limit qualifies for L'Hopital's rule. Okay, let me erase these things over from here. Using L'Hopital's rule, we get this limit is equal to the following limit. Limit x going to 0 from right side. On the top, we take the derivative of top. Derivative of natural log of x is 1 over x. Okay, now derivative of 1 over x, let's do on side. As we know, 1 over x is same as x raised to negative 1. This is 1. When we take to the top, x raised to negative 1. Now let's find the derivative of x to the negative 1. It's like xn, so n x n minus 1, negative 1 x negative 2, and get rid of negative exponent, negative 1 over x squared. Okay, so derivative of 1 over x is negative 1 over x squared. Okay, derivative of 1 over x is negative 1 over x squared. Before we plug in x equals 0, let's simplify this fraction. So that's limit x approaching to 0 from right side, fraction. So keep 1 over x, change this division to multiplication, and flip this fraction. So negative x squared over 1. Let's simplify. Limit x going to 0 from right side. X, 1x and 1 cancel. So 1 nothing, just negative x is left, just negative x. Okay, and we simply plug in x equal, there is no more fraction, so plug in x equals 0. This plus is just for the direction, so negative 0, which is 0. So the final answer is 0. Okay, for some reason we found 0 times negative infinity as 0, but that's not always the case. Just look at the next example. Okay,